Hello everyone. In this video, we will be solving the problem Decode Ways. The problem statement is a message containing letters from A to Z can be encoded into numbers using the following mapping, like A is represented by 1, B by 2, and etc. until Z, which is 26. We have been given a string with numbers and we have to find out in how many ways we can decode it into letters. If you look at the first example, the string is 12, so it can be decoded into two ways. We can either make 1 and 2 separate, as 1 and 2 individually have their respective letters or alphabets A and B, or we can club the two together and get the letter L, which is also a valid letter. If you look at the second example, 2 to 6, this can be split up into three possible combinations. Individually, you can still build a string like 2, 2 and 6, which will become BBF, or you can do a combination where you can say 22 and 6, which will give you VF, or you could make 2 and 26, which is B and Z. So there is three possible combination. One of the criteria that they have mentioned is you cannot have a number starting with a letter 0. So if you get anything like 06, 01, 00 or anything of that nature is not acceptable. So we need to make sure that our logic or that our algorithm cover that scenario as well. This problem can be solved into multiple ways. You can build a recursive algorithm that will iterate through all the letters and then try to build it. You can also build brute force algorithm that will iterate through all the letters in the string and find out the possible combinations. I am planning to use the binary tree depth first search approach to solve this problem. So let's dive into it. So we will be using the example 11106 as our string. In this problem, we have two possible combinations. We can either take one letter or we can take two letters. For example, in here, if I take one letter, I will get 1, and if I take two letters, I will get 11. So I will use these two possible cases and build my binary tree. So I will put all the 1 letters on the left hand side and I will put all the 2 letters on the right hand side. So this is going to be my basic approach. So let's start building our binary tree. Now if I start building my left leg, I will be splitting the first letter and the remaining will stay as is. So I'm splitting out the first letter and so 1 goes out and my remaining is 1106. So now when I split up something, I need to make sure that the character that I'm splitting out is valid or not. Because I'm splitting out one character, the validation is it cannot be 0. It can be anything from 1 to 9 because all the numbers from 1 to 9 are valid as it has its equivalent letters, but we don't have one for 0. So if I get a 0, it means I cannot continue further and I will have to break the loop. So in this case, because it is 1, it is valid. Okay. Now I will continue drilling down further. So for the remaining characters, which is 1106, I will again break it down. So I will do something like 1 comma 106. This is also valid as 1 has its equivalent letter A. I'll continue drilling down. So now for 106, it will become 1 comma 06. Again, this is a valid one. Now I will try to break 0 and 6 apart, so which will become 0 and then 6. Now here's the problem. 0 is not a valid acceptable number. So it means this cannot be broken further and we cannot build a combination based on splitting the individual characters throughout. So this is wrong, so I cannot continue further. If I try to build the right hand side from 0 6, if I try to do 0 and 6, now here I don't have anything left because I only have left with two characters, but one of the condition that we had is if we have two characters, it needs to be greater than 9 because you cannot build a number with 0 in it, like it should not start with 0. That was one of the condition that was given in our problem statement. So again, this condition is not satisfied, so this combination cannot be built. Now I will go a layer up at 106, and now if I try to split it by taking the two characters out, I will get 10 6, which is valid because 10 has its equivalent alphabet. Now I can continue build an LHS for 6 6, and I don't have anything left here, so it's going to be blank. It means we have broken our input or decoded our input based on this combination. So now our combination is 1, which is A, then from this way this, and then we came down here, broke it into 10, which is J, and then 6, which is F. So we built our first possible or valid combination so far. Now if I'll go a layer up, going back to 1106, now I'll try to break it with two characters out. So 1106, again 06 is not valid, so I cannot continue further. I will cross it out. So we have done everything on the left hand side if I'm starting with splitting out one character. Now let's do the right hand side. Coming down here, so now my characters will become 11106. Similar to the left hand side, I will continue building on the right hand side. So I will have 106, I will do 1 comma 06. So this 06 is not valid, so I will not continue further. I will go back to trying to split it into 10 comma 6, which is valid. I can break it into 6. So now I have found another combination starting from 11, then I'm coming down to 10, and then coming down to 6. So my possible combination that I built here is 11 is K, and then I'm building 10, which is J, and then I'm building 6, which is F. So with this input, we can build two combination or two decoded messages. Our time complexity with this solution is O of n square. The reason is we are iterating through the list multiple times for LHS and then for RHS. Okay, and our space complexity is O of 1 because we are only storing the result of how many combinations we have built. Ideally, we don't need to save this word combinations as it is not asked in the question, but you can just store the result like a counter. If you observe something, the 106 that we found out here, we have already done the same combination on the left hand side. It's the same thing. So what you can do is you can introduce memoization or some sort of a caching where you are using the index of the string or the character and save the number of combination that you have accumulated or calculated and use that for the future calculations. For example, if I were to do this combination, so at every point, if I supposedly found a valid combination here, so what I can do is I can save this combination like using the index and the number of combination that I could build somewhere in the cache, and each layer I can keep on adding another entry in my cache to make sure I have the whole record. So when I'm trying to iterate through it again, in this case, I will be checking the cache first and validate if it was already calculated. If it was calculated, then I can directly extract the cached value and increment my counter, which would have saved me this compute time. If suppose we introduce the caching mechanism, then my time complexity will be cut down to O of n because I am iterating through all the letters only once, and my space complexity will be raised to O of n because I'm saving the cached value for each combination of I or for each index. Make sure that you are using the index as a key instead of the number itself or the substring itself, because there is always a possibility that the same set of number or combination of input is there in the string multiple times. So index is the only unique key that you can use safely without worrying about the possibility of the characters being repeated. I hope you were able to understand this approach. Let me show you how you can implement it using C#. Here is the C# implementation to solve the problem. For caching, I am using a dictionary of int and int type and initializing it in my main method. I have built a helper method called iterate which contains all the logic. I start with verifying if the index that I'm passing is already available in my cache. If it is available, then I return the value from the cache itself and save the compute time. If it is not available, then I start with calculating the LHS part. So I extract the first number from the left hand side and verify if it is valid or not. For one digit number, the validation is it cannot be 0. So I'm verifying that if the condition is met, then I continue iterating further all the LHS side because it is a depth first search approach and try to find out if the combinations are valid or not. If all the combinations are valid, then it would come to this condition where I is equals to the string dot length, which means we have iterated through all the combination and everything was valid so far. In that case, we will return 1, which is captured in the temp result in the flow. After calculating the LHS, we start with the RHS. The first step is to make sure that the index that we are pointing at can do a substring on that. It means we have one more character after that. So we are validating it on line 49. If that condition is met, we then start with the RHS where we are taking the substring of the two characters from the current index and verifying using our rule that we define. So the num2 needs to be greater than 9 and less than 27. If this condition is met, then we continue with iterating even further. So we call the same method again. After calculating the whole flow, we are recording the result in the temp result variable. So we are adding the result from the LHS and the RHS and then adding it to the cache on line 62 and then returning the value from the cache. At the end, this method is going to return an integer which is being captured here in the result variable, and then we return the result. I hope you were able to understand the explanation that I provided to solve this problem. After you understand the approach, the building a solution or writing it into code is pretty straightforward. As such, there's no complexity involved over there. The important part was to understand how this can be broken down into smaller problems, and that's what I tried to do that here. If you have any comments or suggestions, please feel free to reach out to me. I would happy to hear your thoughts about this problem and the solution. This code will be available on my GitHub repository. You can check it out from there. I will be adding the link in the description too. Thank you for watching this video and I hope you have a wonderful day.